Okay, so we're going to look in simplifying exponents. And our first question there says, how can we simplify 1 over 64 as a positive exponent? Okay, so what we have here is we want this base to be an integer. Sorry, actually this one we don't want it to be a positive exponent. We just want to simplify this in some way so the base is not a fraction. So to change this not into a fraction, why don't you think of this like it's actually to the power of 1, all of this entire fraction. Okay, and you can invert any fraction by changing the overall exponent to a negative. So if we change that to a negative, this is also equal to 64 over 1, so we've inverted it, okay, to the power of negative 1, okay? Now, 64 divided by 1, do you know what that equals?
64.
Yeah, we don't actually have to include that one. So in other words, this is also equal to just 64 to the power of negative 1. Okay, so we've now made it, I shouldn't say positive exponent, I'm going to cross that out. We've now made it 64 to the power of negative 1. Positive exponents are for the next couple of questions. Another thing they might want us to do is to simplify this with the smallest integer possible as the base. So I have to think of a number that when I multiply it many times, it actually equals 64. Okay. One of the numbers we can use is 8. We know 8 will work. And one of the ways we can do this is by looking at prime numbers. Do you remember doing prime numbers at all?
Not really.
Okay, that's okay. We're going to go and take a look at some prime numbers, and that way we can get a much nicer base. What we're going to try to do is think of numbers that are close to each other that we can multiply. So this is called a factor tree. So I take 64. Can you think of 2 numbers that multiply to 64?
8 and 6.
Close. Actually, 8 and 8 both work. Okay. So technically, that means 8 squared will take us to 64. But in prime numbers, we try to go even lower. Can you think of 2 numbers that multiply to 8?
1 and 8.
Yeah. How about 2 other numbers? With primes, we try to not use ones.
2 and 4.
Yeah, 2 and 4. Okay. And that means this breaks into 2 and 4. Okay. Now, those aren't the same. So, for instance, I couldn't put this base 2 because 4 is not the same number. But can I break 4 up?
2 and 2.
Yeah, 2 and 2. And do that twice. So what this is telling me is that 2 times 2 times 2 times 2, I should write it up here, times 2 times 2 is also equal to 64. So how many 2's is that? 1, 4, 5, 6. So in other words, 2 to the power of 6 also does it. So I could represent this 64 as either 8 to the power of 2, and technically there's still a negative 1 on the outside, or 2 to the power of 6 to the negative 1. Okay? And do you know the power of a power rule with exponents? Wouldn't it have a power and another power outside of it? What we can do with them?
You add them together.
That's if we're multiplying exponents. This is called a power of power. You actually multiply these two together. So what would 2 times negative 1 be?
Negative 2.
That's right. So in other words, this could also be written as 8 to the power of negative 2, or 2 to the power of what?
Negative 6.
Negative 6. So we did all that work to essentially find that 1 over 64 is actually equal to 8 to the power of negative 2, or 2 to the power of negative 6. Okay, we can write it either way. Okay, the next one, they want us to simplify this. Now, because they're adding, I can't actually use any of my exponent laws. And my exponent laws only work for when we're multiplying exponents. So if I had like 6 to the power of 2 times 6 to the power of 3, okay, that would tell me to add the exponents. That would be 2 and 3. If I have 6 to the power of 2 divided by 6 to the power of 3, that tells me to subtract the exponents. And then that power of a power rule we just talked about, where we multiply the 2 exponents. Okay, that dot just means multiply. Because it's added, there's nothing I can do here. But how can I make this a positive exponent, this 6 to the power of negative 2?
Divided by 1.
Okay, well, think of it like this. It's divided by 1, that's right. And how do I make this exponent positive? What do I do to that fraction?
6 times negative 2.
Well, we don't bring it in because the exponent here is technically 1. What did we do over here with the 64?
We reversed it.
We reversed it. And that's how we would make this exponent positive in the long run. We would reverse it. Okay, so I'm just going to move this down so we have some room. We'll move this one down after so we have something else though. Okay, so we're going to flip that. So the question now reads 6 to the power of 2 plus 1 over 6 to the power of to the power of positive 2. Okay. Well, now I can equate these. Do we know what 6 to the power of 2 is actually?
36.
Yep. So 36 plus, so that was the first part. Second part, I got to do 1 over 6 times 1 over 6. So I'm going to do that in blue over here. 1 over 6 times 1 over 6. So with fractions, we multiply top by the top, bottom by the bottom. What do we get?
1 and 36.
Yeah, 1 and 36. So 36 plus 1 over 36. So you can make this a mixed fraction or an improper fraction. Okay, as a mixed fraction, it would just be 36 and 1/36. Okay, but as an improper fraction, I'd have to make this have a denominator of 36 and go through all that work. Okay, I'll leave that to you to do if you wanted to, but otherwise this is acceptable. 36 then 1/36 is a possible answer. Okay, this one here, we just want a positive exponent in this question. Okay, so what do we do to make this a positive exponent?
Reverse it.
So this is also equal to what?
5 over 6.
To the power of?
Negative 3. Well, positive 3 now.
Positive 3 now. Yeah, those two things are equivalent. Good, that was simple. And the last one, all of those little exponent rules we talked about. We want to try to simplify this as far as possible. So this is a power of a power. What do we do with those two if there's a power of a power?
Multiply them.
Multiply those. So what is 2 times 3?
5, 6.
Yeah, it's 4 to the power of 6 times 4 to the power of 3 divided by 4 to the power of 6. Okay, next one. These are multiplied by, so what do we do to the two exponents if they're multiplied?
Multiply the powers first.
So if it's multiplied, what do we do to these two?
Oh, we add them.
Yeah, that's right. We add them. So we're going to add the two. So what's 6 plus 3?
9.
Right. So how do I write this?
4 to the power of 9.
Yep. Divided by?
4 to the power of 6.
Okay. And the last step here. These exponents are divided by each other. So what do I do with those?
You multiply them.
If it's divided, we'll go back up and look.
Subtract them.
Yeah. So we subtract those two. What do we get?
3.
Yeah. So simplified, that is 4 to the power of 3. Okay? We went through a lot of rules there. That was a whole bunch of information in one, 4 different questions. Okay, but just rewatch it and we'll go through it again to make sure. Does that make sense, kind of?
Yeah.